is nothing new. All we're going to do is do compositions of transformations, which is just a fancy way of saying more than one transformation at the same time. So let's look at this example. We're going to do two things here. We're going to start with this ordered pair, and we're going to reflect it in the x-axis, and then, that's the first thing we do, and then we're going to do a translation. No big deal, right? So we got to do these one at a time, though, right? The translation is the easiest part. What about the reflection in the x-axis? Okay, so reflection in the x-axis. What does that look like? I'm going to use this opportunity to kind of just review how we do that. Because remember, that we can make this stuff really simple. Our goal is to come up with a rule and then just follow the rule. So let's think about that. If we go back to, here's and this is how I think you should do it. Here's just an XY plane. If I want to reflect the coordinate plane in the x-axis, what does that mean? This stuff up here is just going to end up being reflected down there, right? And everything down here gets reflected up to there, right? So doesn't it look, will you tell me, what's it look like after I do that? What does my new coordinate plane look like? Does the x-axis change? X-axis stays the same, doesn't it? If I reflect the x-axis on itself, if that's the fold in the paper, the x-axis doesn't change, right? So that looks same as always. But what happens to the y-axis? It gets flipped, right? The fold in the paper means that the top part gets folded down to the bottom part, and the bottom part gets folded up to the top part, right? So it ends up looking like this. So what's my rule then? We just want to come up with some rule It's pretty easy to do. All we have to do is say we started with a normal XY plane and we ended up with this one. So we just ask ourselves, well, whatever is here, that's our new x-axis, right? Well, what is it? Same as the old. Didn't change. So whatever is there goes there. X stayed the same, but what happened? Oops, sorry. What happened up here? We want to look up where normally the positive y-axis would be, and what's there instead? Negative y. So that just tells us that that's my rule there, right? Okay. I start with x and y, and I end up with this. So let's just take a sample point. What if we take the point -4, +5? What are we going to end up with? Well, what's my value of x and y starting out? X is what? What's x? -4, yeah. So x is -4, what's y? 5. All we do is just follow the rules. Okay, so what do we get? What goes there then? Well, hold on. -4, right? Whatever x is, x doesn't change. So that part stays the same. What goes there? Negative y must be what? -5. Done. Right? Once you come up with the rule, things are simple, right? Okay? So I'm just going to copy that rule. So there's the first thing we do. We're going to take our starting point, which is over 2 and down 8. So, it doesn't need to be exact. I don't think you need to make this exact on the graph paper. You can, but you don't really need to. So right there's my starting point. Over 2, down 8. And we're going to do this rule. So what do we end up with? X is 2, y is -8, right? So Shaw, what do we get for after we do the reflection? Where do we go? What's our new x value? 2? 8. Yeah, because the opposite of y is going to make that positive. Good. So over 2, up 8. So right there. And we're done with step 1, right? We did the reflection. Now all we have to do is just do this translation. But man, that's easy, right? That's the easiest stuff to do is the translation. Okay, so Mary, what am I going to get when I do this I follow that rule. So now I've got a new x and y value, and I'm going to do that to it. So what's my x value going to end up being? Well, okay, but I'm going to subtract 4. This is what I'm starting with, right? And I'm going to do this to it. So this one, we can kind of almost erase that. We took the starting point and we reflected it, and we ended up there. Now this is step 2. So my starting x value is 2, and I'm going to subtract 4 and get what? Negative 2. Good. So we're going to get negative 2, and what's my y value going to be? 13. Yeah. And that's it, right? So we just go back 2 and up 13. And that's my answer. And really all we did is we just went backwards 4 and up 5, but we don't need to write that, right? We just apply the rule. Okay, make sense? Okay, let's look at another one. So what about something like this? So enter an ordered pair corresponding to 180 degrees clockwise rotation of this point about the origin, followed by a reflection in the line y equals negative 4. So let's take this in pieces. So step 1 is 180 degrees clockwise rotation about the origin. Okay, so let's go back and let's create a rule for that, right? And I think what's really helpful here, and it's, you know, I would do this if I were you. I would just maybe it's just an index card or a piece of paper that's got an XY axis on it, you know, an XY plane, and let's just rotate it. So what happens if I take an XY plane and I rotate it 180 degrees, and I think maybe it said counterclockwise, but does it even matter? For rotating it 180 degrees, that's a full half turn. It doesn't really make any direction or any difference what direction you rotate it, end up at the same place. Just think of it in terms of quarter turns. 180 degrees is 2 quarter turns, which is a half turn, right? And so what happens? What's my XY plane going to look like after I do this? If I take the whole thing and just go like that, where does the x-axis point after I do that? Yeah, okay, to the left, right? So it's going to look like, how about the y-axis when I do that? Where does it end up? Yeah, upside down, pointing down, right? So it looks like, so what do I end up with? So I start off with a regular XY plane, and I end up now, what's my new x-axis? What's there? Negative x. What's there? So what did I really do? I'm just starting with x and y. What do I do to them? Yeah, I just flipped them. I just make them opposites, right? So there's our rule. Let's grab that. So there's my rule. So if I start off with the point negative 2, positive 14, so it's, you know, like right there, sort of. And I do this to it, what are my new x and y coordinates? Casey, what am I going to get from my new coordinates if I do this rule? 2, negative 14. Good. So we'll just go over 2 and down 14. And you notice, I don't know if you've noticed this, but when we rotate 180 degrees about the origin, I want to point something out. Do you notice that relationship that it always, if I take those 2 points and I create a segment, the segment always goes through the origin, and the origin is the midpoint. We'll talk more about that in the future, but that's some symmetry that might make it easier to draw at least. So we get to here. Now we've got to do step 2. Step 2 is a reflection in the line y equals negative 4. So real quick, let's just remind ourselves, what does that look like? Let's draw the line of reflection. So whenever we have weird lines like that, x equals a number or y equals a number, we always know what kind of lines are those going to be? Horizontal or vertical. Good. We just have to ask ourselves, which one is it? Well, this is essentially just telling us where it cuts through that axis. So if it's cutting through the y-axis at negative 4, this is the y-axis. Is that going to be a horizontal line or a vertical line? It's got to be horizontal. Yeah, so here's, I don't know if I didn't get this exactly right, but you get the idea. There's negative 4. So there's the line of reflection, right? Now think about what a reflection does. That's like folding the paper along this fold, and I take a point with wet ink and it's gonna make an imprint up here, right? Well, what do you know about how far, okay, so we know it's gonna end up here somewhere, right? The x coordinate's gonna stay the same because we're reflecting it vertically, agree? So we're gonna end up someplace up here, we just need to know where. Well, let's look at this for a second. So what can you tell me the distance that the pre-image is below the line of reflection? How does that compare to how far the image is above the line of reflection? Got to be equal, right? Got to be equal. So if we could just figure out how far away is the original point from the line of reflection, we can determine how far the final one is away, where it belongs. So what is this number? Now, it's 10, isn't it? Good, because we know that the y value of this line is -4, and the y value of the point is -14. We have to just ask ourselves, how far apart are the numbers -14 and -4, right? That make sense? And you can subtract them. I mean, we could say -4 minus -14. Let's put that away, please. Like in your pocket away, how about? So -4 minus -14 would be like adding 14, which gives us +10. But you could also just think about it this way if you wanted. You could just say, okay, well, if this distance is 4 and that whole distance is 14, then how far apart are they? Well, that must be an extra 10, right? So we know that distance is 10, so that distance needs to be 10. So where do we end up? If we start at -4 and we add 10 to it, -4 plus 10 is what? 6. Yeah, so the y value must be 6, right? So we end up with coordinates. The x coordinate stays the same, right? So 2 stays 2, but the y coordinate becomes +6, right? And that's our answer. Okay? Make sense? I mean, there's a little bit to it, but it's not like it's horribly complicated. You just got to be careful. Just be careful not to make a mistake. Okay, last one. This is a little tougher. I'll probably give you, yeah. So I'll probably give you one of these to do, but notice the thing that makes this a little bit tougher here is that we're doing a rotation about a point that's not the origin this time, right? So look at this first step. We're going to rotate 90 degrees counterclockwise about the point -2, 3. That's a little weird. So our tack is going, this time it's going back 2 and up 3. So that's the center. Okay, what point are we starting off with? Well, it's the point +5, -8. So say it's down, it's like down there somewhere, right? Okay, how do we do this? There's a couple ways you can do this. I'm gonna talk about a way you can do this that later on, if you continue with math and science, you'll do it this way. But for now, it's not really essential. What we can always do, and I just want to make sure this sort of makes sense to you. Wouldn't it be more convenient if the tack, meaning the center of the rotation, were on the origin? That makes the rotation easier, right? So one thing we could do is we could take everything on the plane and we could just shift all that stuff down. So we're shifting the entire plane down 3 and to the right by 2 to locate the center there, right? That's going to move these coordinates to a new spot, and that's okay. But after we do that, we could shift everything, and then we could do the rotation with our tack being on the center. And then all we'd have to do is just reverse the shift. Whatever we did to move this point down to the center, now we'll move it back that same amount. That's an okay thing to do. To translate, then do the rotation more conveniently, and then reverse the translation. Okay? I want you to be aware of that. You can try it. I mean, it works. But I'm going to show you maybe for now an alternate way that's more of a vector approach that I think fits with what we're talking about a little bit better. Couldn't we just do this? And I think this is a great way to think about it. If we think about the horizontal and vertical parts of this distance, right, we can just rotate those. So if this is the center of the rotation at -2, 3, how far do we have to move horizontally to get to the point that's being rotated? From -2 to +5? 7. Okay, so we're going to go over. So that segment has a length of 7. How far do we move vertically to get from 3 to -8? So we would go down 11, but we know that the length of this segment, the vertical segment, would be 11, and they're at a right angle. Does that make sense? Everybody with me? Okay. In other words, if we had to give an ant a roadmap or directions to get from the center to the point that's being rotated, we tell the ant to walk to the right 7 and down 11, right? Okay. Let's rotate everything, including our directions, our roadmap. If we're going to rotate 90 degrees counterclockwise, then where does that green segment end up if I take everything and I rotate it 90 degrees counterclockwise? Instead of pointing to the right, where does the green segment point now? What do you think? If I rotate it 90 degrees counterclockwise. Point straight up, wouldn't it? So it would go like this, right? So that would be the new segment, right? Because we rotated it 90 degrees counterclockwise. So then where does the purple segment end up being? Well, the purple segment is at a right angle. It used to go down. Now where does it go if I rotate it 90 degrees counterclockwise? To the right, yeah, good. So we could say we started off with this, but we ended up with that, right? All we got to do now is just figure out where does that leave us. So we end up with coordinates where? If I start at -2, 3, and it looks like I'm going to go to the right by 11, what's my x-coordinate going to be? If I'm starting at -2 and the ant is going to walk to the right by 11, so +11. 9. Okay, what's the y-coordinate going to be? The ant starts off with a y-coordinate of 3 and he's going to walk upward 7. What are we going to get? 10, yeah. Does that make sense? So that's where we end up, yes? Yeah. So that's where we end up after the rotation, right? That's the hard part. From here on out, it's not that big a deal. So what's left to do? We're going to reflect in the line x equals -5. So that's going to be kind of messy. Can I just erase all this stuff over here? Is that okay? I mean, you see how we got there, right? We took the segments and we rotated. So now, let's just do this. Okay, so now we've got to reflect over the line x equals -5. Where does that line go? So Molly, if we're the line x equals -5, it means it's got to cut through the x-axis at -5. Is that going to be a vertical line or a horizontal line? This is the x-axis. It's got to cut through the x-axis at -5. Yeah, so it'd have to be vertical, wouldn't it? Right. So we'll say this is our line of reflection. X equals -5, and we'll play the same game we did before. We know that we've got to end up with a point that's just as far to the left of that line as the starting point is to the right. Okay, so we end up, someplace over here, right? Well, what's it going to be? What's that distance going to be? Caitlin, if we want to find the distance from -5 up to +9. So what's that total distance? 14, yeah. Because we know this is a distance of 5, and then we got to go an additional 9 to get there, so it's a total of 14 away, right? So then I've got to go backwards 14. So where do I end up? If I start at -5 and I'm going to go to the left, so in the negative direction by 14, where do I end up? Yeah, -19. Good. So the x word, what's that? Yeah. So we get -19. Does the y-coordinate change? It's not going to change because I'm doing a horizontal movement, right? I'm reflecting it only horizontally. So this is still going to be 10. Okay, so that takes care of, we're done with step 2. Last step is the easy part. That's the translation. Well, now it's just a matter of doing that, right? So Bailey, where do we end up? If I'm going to start here for my last step and apply that rule, what's my new x value going to be? See?
Yeah.
Okay. So the rule is telling me whatever my x value is, I'm going to subtract 8. What am I going to get? So what's negative 19 minus 8 more? $27, yeah. So we're going to get negative 27. What about my y value? I'm starting at 10 and I'm going to subtract 12. Negative 2. So if we put it on the graph, it's just going to be, back here somewhere, I guess, like right there. But the important thing is just the coordinates. It's negative 27, negative 2, and that's my answer, right? You just got to take it one step at a time. Okay? Make sense? That's it. Okay, we're done. Head over. I've got Chromebooks.